So I'm supposed to make converting English and metric measurements interesting. Okay, I guess. I'll try some drama. This stuff is important, English measurement, so let's make the most of it. Let's look at the next slide.
I don't like King Julian. I love him. I love you. What? What are you doing? Thank you, Luffy. I will love you forever. And now I give you all the huggies in the world. Don't.
I think of a couple different things when I think about feet. One is Mort from Penguins of Madagascar, and the other is feet as in inches. And believe it or not, there is actually a connection. English measurement, like with feet and inches and miles, have some interesting legends and history. One legend or piece of history has to do with King Henry I's size of his foot being a measurement they're going to use for feet. So feet actually does measure with foot. So some king's foot was 12 inches. Moving on. Here's another good one. A yard was determined by how far the distance was between this king's nose and his thumb. That's a good one. This is a good one, and it seems to be more connected to actual history. So the Latin root of mile is mil, like millennium, which means 1,000. Mil means 1,000. So 1,000 Roman legion double steps was supposed to equal 1 mile. So that's where we get the origin of mile, which means 1,000 Roman double steps, which hardly seems standard if you think about how they might apply to other countries or around the world. These different measurements didn't really help people because across countries, everyone had a different sense of measurement. So in 1795, the French came up with an idea to do things based on tens, which makes sense mathematically, is more standard. And what they did was they had figured out, using math, the distance of the circumference of the Earth. So they started to use that as a standard. So what they did was take the distance between the equator and the North Pole, and so they used that distance just to establish it as 10 million meters. So we get 1/10,000,000th of that would be 1 meter. So the meter, which is the standard, comes from the distance between the equator and the North Pole. So 1/10,000,000th, the distance between the equator and the North Pole is 1 meter. Here's a cool piece of trivia. There's only 3 countries that use the English or imperial system. It's the United States, Myanmar, and Liberia. They're marked in red on this map. So this is some of the easiest math we've done. To build a new swing, Mr. Madison needs 9 feet of rope for each side of the swing and 6 more feet for the monkey bars. The hardware store sells rope by the yard. And we know there are 3 feet in 1 yard. So if you bought 1 yard, you'd have 3 feet. If you bought 2 yards, you'd have 6 feet. If you bought 3 yards, you'd have 9 feet. So some of this would be really easy. Directions for this one are just weird. Anyway, you know you need 3 yards on one side, 3 yards in the other side, and what goes in the middle? How many yards go in the middle? That's what I think makes the most sense. And I think the rest of the page works out just fine. Okay, here's one page or another page where the directions are more confusing than the concept. It says I need to convert 2 miles to feet. So 1 mile is 5,280. So what you would do is I need to multiply the total number of miles by 5,280. So it would be 2 times 5,280. Okay, step 2 means you have to read the top part to understand step 2. It says the distance between the new high school and the football field is 2 miles. How does the distance compare to 10,000 feet? So you need to know if 10,000 feet equals or is less than or greater than 2 miles. Okay, I'll help a little bit with this page with a few of them. It says 125 inches equals how many feet and how many inches. So what you would do is divide by 12. You got it? Okay. So you get the number of feet in 125 inches, and the remainder will be the inches. That's not bad. The next one says 46 feet equals how many yards and how many feet. That's another division problem, except we're doing feet and yards, which includes the number 3. Okay, and you're doing the same thing for number 6. 7, 8, and 9 have to do with greater or less than or equal to. And I'm looking at, let's see, number 9 looks like a good one. I think I'd almost changed number 9 from 3 yards and 2 feet straight into feet first. So 3 yards would be 9 feet plus the 2, and then see if that's equal, greater, or less than 132 inches. That's not that bad. Might be one of the more interesting ones, but pretty easy. Terry's making 6 hat and scarf sets. Now, what he means by that is he's going to make a hat and a scarf that go together, they match. So there's 2 things that he's making per set. Okay. Each scarf requires 2 yards of material, and each hat requires 18 inches of material. How many feet of material does he need? So we're going to change everything into feet. That's my hint for that one. Javon is helping his dad build a treehouse. He has a piece of trim that is 13 feet long. 13 feet. How many pieces can Javon cut that are 1 yard long? How much of a yard will be left? My hint on that is it says how much of a yard is left, not how many feet. So you're going to change it into a fraction. So I don't think I'm going to help any more than that because I think you got it. This isn't so bad. Patty's building a rope ladder for a treehouse. Apparently she needs to go up 5 feet because she needs 2 5-foot pieces of rope for the sides. And she needs 7 pieces of rope that are each 18 inches long for the steps. How many feet of rope does Patty need to make the ladder? Okay, that's not hard. Write your answer as a mixed number and as a mixed measure in feet and inches. Okay. Write your answer as a mixed number and as a mixed number. Oh, okay, I see it. So it's how many whole feet and how many inches does she have to buy? Oh, that's not so bad. So the whole number is going to be feet, and the inches are going to be fractions of a foot. So the denominator will be 12. This page isn't so bad, guys. It's just a bunch of practice, and I think you can manage on your own. 589, even the two-story problems at the bottom, 16 and 17, aren't hard, and just skip 18. Okay, these are a little bit more interesting. Mackenzie works for a catering company. She is making iced tea for an upcoming event. For each container of tea, she uses 16 tea bags. Got it. And 3 cups of sugar. If Mackenzie uses 64 tea bags, how many cups of sugar will she use? Oh, I like that. That's a good one. And I know you can do that on your own. And if not, we can, when we meet on Tuesday, I can help. This one might be even more interesting. Javier bought 48 sports cards at a yard sale. Yeah, this is a good one. Of the cards, 3/8 were baseball cards. So not all of them were baseball cards, 3/8 of them, which is less than half. And I think most people will know to do this. My one hint would be divide. I'm just going to say that. You're going to divide something and multiply by 3. You'll get it. What the answer is going to be less than 48, okay? This isn't so bad. You probably only need to remember that quotient is the answer to a division problem. And number 6, there might be some vocabulary you forgot. It says, what is the unknown number in the sequence? What rule can you write that relates sequence 2 to sequence 1? Basically, just fill out the pattern. I know you're going to find it and explain what you did. It's another instance where the directions are actually harder than the skill you're supposed to be doing. So complete the pattern and then just explain what you did at the bottom. You're done with this week's homework.